Hello, good morning, good afternoon to everyone who has joined this session on Unveiling the Secrets of Computational Fluid Dynamics, organized by noCnX Technology under STEM program. So first of all, we'll understand what is STEM. So STEM stands for Science, Technology, Engineering, and Mathematics. noCnX is currently working with the industry and educational field to develop the resources who can be easily, you can say, who can easily absorb into the industry for the industrial projects. So in STEM, we are currently working on different programs for training the engineers, not only just students, but also you can say the researchers, then also the professors to bridge the gap between industries and institutes. So yeah, next slide. So today I would like to introduce our key speakers. So our first speaker, industry expert is Siddharth, who has worked with computational fluid dynamics for more than 15 years of experience. Siddharth, who has worked with different industries, which include automotive industry. He has worked with automotive HVAC design, AC design for the flow and thermal related problems. He has also worked with consumer products for designing and developing the refrigerators, where he has used his expertise in the field of multiphysics to design and develop refrigerators for different companies. Currently, in his recent assignment, he is working with medical side for research and development of different medical equipments. So we welcome you, Siddharth, for today's event, and thank you. You have joined for this particular event. Then our
Thank you,
next
Azim.
speaker, welcome. Our next speaker is Mr. Pinaki, who is founder director of noCnX Technology. Pinaki, who has worked with the industry for more than 25 years, and he has a good knowledge, a wide knowledge in terms of product design and product development. He has also worked with multiple industry, which include automotive, off-highway, valves, pumps. In his previous role, he was working as a DGM for the water pump and oil pump design company, and he was handling a team of more than 100 engineers for designing and developing different pumps, which are used in the field of automotive and also in the field of oil and gas. So we welcome you, Pinaki, for joining this webinar. And I know you were busy with your busy schedule, you were traveling, but thank you. You have taken some time for us to join. So thank you very much.
Thanks, Azim.
Yeah. So next slide. So let us understand the today's agenda. So we would like to introduce noCnX technology and like what we are currently doing, what is our expertise, and we also would like to express like what type of trainings we are offering in the year 2024. And after that, we'll be having some question and answer session, and also we can have the next direction, like when we'll be coming with the next webinars and what is our plan for 2024. Yeah, next slide. So to start with, I would like to ask Mr. Pinaki to give an introduction about noCnX technology and highlight on our journey. Over to you, Pinaki.
Thanks, Azim, for giving such a beautiful introduction to everyone. And thanks for sharing those details. So, noCnX Technology started its journey in 2019. And in almost like close to 4 years, we have, grown organically, not only in terms of projects, but also like associating ourselves, with companies outside of India, majorly in US, Europe, Singapore, Hong Kong, and we work heavily in India as well. So in this tenure, we were able to achieve partnerships with companies like Altair, with EMWorks, and we today, last 2 years, we have been heavily focusing on the e-mobility side. And we have now our base in Canada as well, US and Europe, as I mentioned. And today, our backend team sits in Pune and Bangalore, and we are supporting to various customer base in automotive, off highway, in e-mobility, a lot of other fields. We are providing our engineering solutions. So I will, yeah. This is a list of customer. We almost are catering to 25 plus customers here, and we have 45 plus direct and indirect engineers working for various projects. We have our presence in 5 countries, and almost like I would say, our customers today are highly satisfied and giving us repetitive business, and our customer satisfaction rate is 98%. We want to maintain the same and exceed our customer expectations in coming years. Yes, and we have bigger plans in 2024. So yeah, thanks Azim. That's all from my side.
Thank you. Thank you very much, Pinaki, for this introduction. So the first question is like why we need the simulation. So in the industry where we are currently catering to, so you take any industry which is automotive, off-highway, medical equipment, consumer products, anywhere. So it is very important to have a realistic prediction about about the product. So whenever we are designing certain product, just to take an example, like if we are designing a product like the HVAC system for automotive, so it requires multiple things. It requires we have to see the flow rate, we have to see the temperature distribution. We also have to say what is the temperature which is achieving inside the cabin with respect to different combination, like when we have the sun, the radiation model we have the heat from outside, heat from the engine, heat from the people inside. So all this prediction, if we are going for prototyping and then testing in the design cycle, it will take more time, and also the prediction would be late in the design cycle time. So through simulation, you take any software, either it will be from ANSYS, Altair, or maybe Star CCM, anything. So we can have a realistic prediction through the simulation, and we can able to optimize the design. We can able to improve our design by looking into the results from the simulation. So that is the first very important thing for the simulation, to have a realistic prediction. Then the second would be the improved design in terms of optimizing the design. Whenever we have a certain product and if it is failing or if it's not performing up to our expectation, then we have to have a design improvement. So to have that particular design improvement, first we should understand how is our base design is performing. So that is very important to understand that. Then the third very important factor is the cost reduction. When you are doing 3 to 4 prototypes, still you have to pay a lot of cost because you have to prepare your mold, you have to prepare the complete, you can say you have to consider different materials and then go for the production. And also with that, the time it is also required to have all those things. But through simulation on some clicks, you can able to get better results, better prediction, and the cost and also the time for the product design cycle has been improved a lot. So if we have seen from the last decade to this decade, now product design cycle has been improved almost more than 92%. So previously, if we used to design something in 100 days, now within 8 days, you can design that particular thing. So that's the, you can say, the beauty of simulation and the industry where we as an expert coming, so we are helping multiple industries to achieve the product in faster way and to have the improved design. So yeah, next slide. Yeah, so here maybe I would like our expert, Mr. Siddharth, to take over the session and explain like what is the advantage of, so like what are different CFD application and what's the advantage of it. So yeah, over to you, Siddharth.
Thank you, Azim, for the brief introduction. And this is a very important session for students, for the community who are into research and who wanted to take it further, and especially for the industries. So having spent a good amount of years in CFD, I could at least understand where the hello. Yeah, so thank you, Azim. For introducing. And so having spent a couple of years in the last few years in CFD, I can see how the progress of the CFD has been going and how the progress will be in the coming years. So very insightful and knowledgeable sessions this is going to be. So I would like to start with the time when we were starting our CFD career. And at the time then the CFD was limitedly used in automotive there was going on. But we used to hear that the CFD will be applicable in medical industry, the CFD will be applicable in uh, your civil engineering, chemical engineering, and we are curious, like, how this is going to start. Yes, there is physics, but in order to solve that, how the machines would be, how would be the process, how the domain, how the CAD models would be prepared. So there are multiple questions. And today at 2023, when we stand and we see the vast ocean of CFD and its applications in every industry of engineering, you tell it biomedical, you talk about chemical engineering, you talk about civil engineering, you talk about any multidisciplinary, electronics, electrical, there is, say, computational fluid dynamics and its vast applications. So earlier it was aerospace and mechanical, and today you see the vast. So talking about the applications, when we see these particular presentations, you see the vast applications. You see a car and the wakes formation on the car, the third image, which is based on something called as a lattice Boltzmann physics. That is the methods that have been applied in order to solve such kind of a complex application on this car aerodynamics. Then there is something called smoothed particle hydrodynamics, the second image, where you see a large assembly of a large vehicle, probably a truck, and you see the gear sloshing. Whenever there is a lubrication happening in a gear, how the process actually happens, we can see in our own monitor, and that helps an engineer to take proper designs. Then aerospace, you see the first image, there is a fluid and there's a structure, and the structure is moving, and those kind of physics can be applied. And talking about biomedical, talking about civil engineering, pump industry, and then there's a very beautiful image where you see refrigeration at the bottom on the left side, where there's a fan which is trying to flow the air and passing it to certain important compartments of a refrigerator. So such kind of things are visible in our eyes, and this all works on the underlying principle of fluid mechanics. And talking about the biomedical industry, talking about the pump industry, two industries where I am very closely associated in my couple of years of experience in my previous organizations and current organizations. So I'm enjoying every single moment, and there are a lot of student communities, there are a lot of interns, there are a lot of new joinees who are working closely with me, and the kind of future that I am seeing on the students is amazing, especially who have applied or who are working on CFD and taking this as a field right now. So that's the CFD vast applications. uh, Maybe I would like to talk more details in the next slide about a case study, about the findings, which is going to be on a very, very interesting topic, that is our e-mobility. Wherever we go, wherever we see, there is a talk on e-mobility. Our country is going towards a rapid industrial change on e-mobility. Not only India, but you see the globally, you talk about South Asian countries, you talk about Europe and the US, every work is into e-mobility. And there's a very famous saying, the future is electric. So that is the whole thing. So talking that noCnX technologies and its experienced vast engineers came for a very successful project of a very renowned Indian startup, which is Suyo. And I was very happy that I was a part of this work. I could contribute as a mentor on this project in solving some of the complex physics using simulations. So this is one of the success story where you see an Indian organization, Suyo, which manufactures BLDC and other various types of motors, and they came to noCnX technology to solve some of their critical issues, especially at design stage, solving the temperature rise of the motor. Because when any motor manufacturers develops a motor, in India especially, the temperature conditions in our country varies so drastically, talking from the Jammu to Kanyakumari and from the Gujarat to Arunachal. So manufacturing or designing or anything related to a motor under such a varied temperature conditions is quite critical. So the only way to solve such kind of a concerns of a temperature rise is through a simulation procedure. And noCnX, along with Suyo, together they have developed a very robust simulation procedure in which whenever any raw model of a design or at a very conceptual stage of a motor is prepared, at that stage noCnX technology came with their expertise of simulations and developed and gave right decisions at the very initial stage to Suyo. And for example, if you can see on the images, there is an EMAG, so which is nothing but electromagnetic simulations. So the motor before its production, it is helping, we can identify where are the flux lines, what are the concerns in terms of electromagnetics. So that is being developed. After that, the electromagnetics results are transferred to a CFD, where the CFD engineer predicts the temperature rise in the motor and can tell what should be done in order to reduce the temperature rise at certain regions. And after that, talking about the structural integrity, the same procedures of the CFD results are being mapped to the structural engineers to develop what is the effect of the thermal, what is the effect of the pressure, and how it can affect the motor in terms of its structural integrity as well as noise and vibrations. So that particular physics developed by the noCnX engineers helped the organization Suyo to take right decisions, prepare the right combinations of designs, and it has drastically helped in the entire product development cycle. So this was a very successful case study of e-mobility, and I'm really thankful to Pinaki for considering me a part of this very important and a remarkable project. And multiple works are there working on this e-mobility, and I'd be very happy if anybody interested can connect to us and connect to me, connect to Pinaki and the noCnX Technologies for any motor related solutions. So going back to another case study, which is related to the pumps. So yeah, so pump is one of the area where I very closely have worked in my previous organizations, and this was again a very challenging problem. So simulations, yes, it is very nice. It requires practices, it requires experience, it requires skills. But whenever the simulations and the test comes one in one, the whole thing becomes really beautiful. So it was a great opportunity for the noCnX engineers, where first of all they got an opportunity to work on this radiator pump, where the customer wants to understand the flow behavior inside the pump, and based on that they want to take certain decisions like improving their impeller, improving their volute, improving the suction, improving the delivery. So there are multiple things they wanted to understand, and also they want to understand the structural integrity. So but before that, it was an opportunity for the engineers to visit the test rig and see how the testing is being done. So testing, if you see the images on the right side where a test bed is shown and you see a pump and there are multiple devices which are associated with the pump test. So there is a test rig, there is a suction pipe, there's a delivery pipe, there are multiple measuring devices which measures the fluid pressure. And based on that, all these informations are taken and a CFD model has been prepared in accordance with a test rig, so then there is not a chance of any error. So it is as accurate as a test. So whole test scenario is prepared right now in virtual environment. You can see the whole thing, and then you can see on the animations, the flow animations of the pump is shown very beautifully, and a very accurate results have been done. And these helps to design the pump efficiently. Also, you can see the structural model also, in which the deformation and other parameters can be studied, which helps the pump manufacturers to take the right decisions. And also, most importantly, a graph has been plotted which talks about the correlations level of the test, where the engineers of the noCnX visited and observed the test, to take in the text, take in the readings of the test, and then simulated, and they did a correlation among that. So this is a kind of they have done the pump work, and that is very, very accurate. Yeah, so going ahead, on the next slide. So you everybody have got an idea the importance of CFD and how it can help us. Speaking about the two case studies in the last to present in the last two slides. So noCnX CFD training is quite robust, and probably it has got everything that somebody wanted. So obviously CFD applications, we all know it has reached to all the domains of the industry, and it has reached all the domains of our engineering curriculum. So there is demand for a computer engineer to to join CFD industry. There's a demand for a civil engineer. There's a demand for an automotive. There's a demand for a biomedical. That does not matter. Where earlier it was only for a mechanical or an aerospace. Now, based on that, they have prepared a very beautiful curriculum which has experts from the academia, which prepares the whole curriculum, especially the theory part. There are classes, there are assignments, there are doubt clarification sessions. Then there are projects which are developed by industrial experts. So I, being into an industry, I will be helping the noCnX team to get projects which are industrial based and where students can do the projects live. So this is live project options, and there is a very useful thing, that is a mentorship program. So mentorship program is a very widely developed. This is for the students and also for the faculty members also. So that's an important thing. It's not only for the students only, it's for the faculty members also. Students mentorship is very well defined. They can be in touch 24/7 on live chats. They can come face to face on the mentorships. They can talk to the mentors on their future career, also in the project. So multiple things. So this is a very nice curriculum they have prepared. More details I'm going to talk in the next slide. Yeah, so this are the three courses which are prepared. One is your advanced CFD course, very, very important for the students in the final year or just recently passed or maybe on the third year of can opt for these courses. All the courses are based on a 4-month durations. So there will be 2 months of classes generally, or maybe 1 month class, and a combination of project and internship. There are options where students can participate on the classes depend on their curriculum on weekdays or weekends, and each courses will have recorded sessions. So that's something very important. So talking about the first course, which is advanced CFD course. So advanced CFD courses will have all those theory and practical sessions prepared by the industry and the academia experts, which will be for the 2 months, because there will be requirements because students have come from the college or maybe are in the college. That's why a 2 months of rigorous classes will be there. Opportunity for doing projects works from the industry. That's a very important thing. Industrial problems will be given to you, and obviously the mentorship program. So this is the advanced CFD course. Industrial CFD course is for those who have recently passed or may have some kind of an experience working, maybe from a previous internship, or maybe 1 year experience and just passed out and having a 1 year of experience can also opt for this industrial CFD because it is more based on project based. So there will be less theory classes and there will be more of a project based. And obviously the best part is there will be an opportunity created for placement also, which we are working on with the clients that we are working, and also the mentorship program will be there along with that. Research CFD course is for particularly for the PhD scholars and for the faculty members who are already very well versed with the CFD and requires support from our end to connect with the right industry people. So that is for this research CFD course. So these are the three extensively designed courses by the country's very renowned professors and the industrial experts, and I recommend the student community and the teachers and the experienced people also to explore these courses. So that is from my end. Thank you so much.
Thank you. Thank you very much, Siddharth, for giving a good introduction about our courses and what we are going to cover in those particular sessions. And I guess you have really highlighted a very important point about the importance of CFD and the areas where currently CFD is really helping the industry for their betterment of their product design and in the product design cycle. And the courses which you have described, I think that will be really beneficial to the students, you can say to the researchers, and also to the new engineers who are just coming into the industry and what benefit they can take from our courses. So other than CFD, we have three more courses which we have designed for the you can say for the students. So first is into the structural reliability and optimization side. So it is kind of 1 month program where we are first going ahead with the theory, where we are discussing about what is the finite element method, what is the importance of it, and the aspects involved in the product design and why it is important. Then we'll be having we will be having one more session where we have the industrial projects, where we'll be catering industrial projects for like we will be working with the students for the industrial projects, and we'll be giving the live projects from the industry. The second one is into the advanced multi-body dynamics. So that is also very important subject, and we have very good requirement in that particular area currently where industry is moving. So we need to have a proper understanding of multi-body dynamics also. So that is also same 1 month of program where 1 month of project-based learning will be there, and also we can give the internship model also in that. The third course is into the mold designing, or you can say into the mold flow simulation. So that is very important for the industries like who are currently working in the plastic industries. And our experts from industry will be coming together and they will be training them for the same course of 1 month. So the timings and the next updates will be communicated with the students and the colleges by January 2024, and we'll be coming with first, as Siddharth has mentioned, first with the computational fluid dynamic course, and that communication about the timing and the cost, and that will be communicated to respective colleges and the students through via email. And also, I would request you have to please follow our LinkedIn page where we are mostly communicating our upcoming courses. So yeah, I think next slide. Yeah. So if you have any queries or anything related to what programs we are currently doing and what is the upcoming news, so you can always write to our Gmail account for the STEM noCnX at the gmail.com, and also you can visit our LinkedIn page. You can also visit our website for upcoming sessions and upcoming trainings we are coming with. So I guess we have just 2 minutes left in our session. So I'll just want to quickly take one or two questions. So maybe if someone can unmute themselves and if they want to ask some question, they can do, or else from the chat I can read one question, I guess. Yeah, I think Kavita,
Hi,
you can.
Azim.
Hi.
Yeah, hi, Azim.
Hi.
I have a question. I actually working as a FEA engineer from past 10 years.
Okay.
Like I am working on plastic components actually. My
Hmm.
company is in terminals and connectors for this battery pack design and all.
Correct.
So we are into manufacturing of a battery side. So I'm interested for the CFD course. What software you will be using and how you are going to
Yeah.
like
Yeah, got it. I think thank you, Kavita, for
yeah.
asking this question. So yeah, actually, in terms of software, so right now, as I have previously mentioned, like we have expertise from ANSYS Fluent, Star CCM, and Altair Qsol. So all three software we have very good capability, and in the point of training, so it depends on what type of requirement you have. Like for example, if you ask like if you want to go with battery, so I would suggest you we have to better go with star system because the modules which it has related to the cells and the battery chemistry, cell level chemistry, and that integration with respect to your thermal model, I would request you have to go with the star system training which will be coming up. So our courses has been designed in a such a way like in first part you'll be having the best, you can say, better understanding of your basics into the CFT. Then after that we'll be going for the software side. So software-wise, Star system maybe that will be better for you. So that would be my suggestion. But do you have anything
Actually,
particular requirement? So we can also take care in
yeah,
that.
in my company, one guy
Hmm.
is already working on these components.
Hmm.
He is using ice pack and this
Answer this,
one.
okay. Hmm.
Yeah, so first he will be doing in ice pack, I think so.
Yeah, and when you want to start the course exactly?
Actually, I want to start immediately, but not. I'm not looking for daily weekend batches only. I need actually.
Okay, so maybe what we can do, we can connect back again. I think we might have your mail ID, but maybe we can approach and maybe in mid of, or you can say almost end of December, we'll come up with the plan. And if like how many members would be joining for this? So from your organization, it would be just you or any other also will be interested. So we
No,
can have,
I am personally interested for my career growth development because in future everything will be EV vehicles only.
yeah, yeah.
So I want to update myself into EV side. So
Mm,
last 10 years I am working structural, linear, non-linear analysis, optimization, durability and all.
yeah.
So I want to upgrade. This is my own interest.
Okay,
I'm
sure.
looking from company sponsorship or anything. I'm going to pay from my pocket actually.
Okay. No worries. I think we'll be coming up with that program. So I'll update you on that. And I think we might have your mail ID. And also what you can do, you can give your details. You have the stem.stemnocknex@gmail. If you can give your
Yes,
details, your
yes.
contact number and your mail ID and details, we'll definitely approach you and we'll tell you like the next. And if you're interested in NSys iSpec, yes, we can help you in that. And we can have some customized modules for you also to be designed, and we can do that in that way.
Okay, thank you, Ajay.
Thank you. So I think we are just out of time, so maybe we can conclude. So thank you very much for all